Thank you and hello. So yes, my talk today is more accurately named DevOps and the Death and Rebirth of Childhood Innocence. And anywhere you want to find me on the internet, I'm hashtag Robert Douglas or at Robert Douglas. Yeah, there. I'm here today not only because of my long experience with PHP, but because the company which I work for, Platform SH, is a sponsor. There will be a brief advertisement at the end. Promise very brief. And before we really begin, I need to introduce you to Robert's first law of coder dynamics. Okay, pay attention. It says, when solving a problem, as represented by the red dot, and following a logic path in your brain towards a solution for that problem, the larger the topical distance between the current topic and the original topic, the more likely you are to install software that you don't need. So, you've got a safe zone and a danger zone. And once you get out of the danger zone, you just go crazy downloading shit. All right? For example, programmer. I think I'll write an app that helps me identify vintage autos. You know, point your phone at a car and get the model, make a number. Sounds pretty cool. Thought path. Cars, image recognition, training algorithms, Python libraries, C bindings, static binaries. Uh-oh, it's time to download Call of Duty Black Ops 4. Yep. This, by the way, is very closely related to Rob's second law of coder dynamics, which says that for every second of wake time you experience while loading an internet page, the likelihood of spontaneously consuming 1,000 calories in the form of Pringles and Coke increases by 30%. These two principles are actually relevant to the death and rebirth of DevOps, or childhood innocence. That's why I bring them up. All right, let's begin. Part 1, developers. In the beginning, computers were toys. We played with them. Through play, we learned to program. As programmers, the feeling of power and control excited us. When we told the computer to do something, it obeyed. We imagined all of the fantastic programs that we would build. These became our goals. We, as developers, are very goal-oriented people. We learned to problem solve. We were children, innocent children, fascinated with the endless possibilities our incredible toys afforded us. And our childhood innocence allowed us to play without boundaries and thus create the magnificent world we enjoy around us today, full of incredible sites, apps, tools, enabling communication and sharing, improving lives around the world. This is a story of how we've lost that childhood innocence, how it crashes and burns and falls apart, leaving us bitter and confused and unable to focus on the things we want to build. In the beginning, deploying code was fun. You would get these monthly magazines with programs printed on the pages, and you'd type those into your computer. And when I started, as I didn't have enough money for an actual disk drive, I would use the program as long as the computer was turned on, but when I had to turn it off at night because my mom made me go to bed, the program vanished from RAM and it was gone forever. And then later, if I wanted to run that same program again, it was a cost-benefit analysis on how good the program it was. Versus typing it in again. And usually if I decided to type it in, it was because I wanted to hack it. I wanted to extend it. I had some ideas to experiment, to play. I was innocent. Later, with a disk drive that I purchased with Christmas and birthday money, I'd go over to a friend's house with the drive, make copies of the program, and then I could run those programs at home, too. These programs were scripts, and they just ran, trademark. The computer interpreted them. They used languages like BASIC, or later Perl, or even later PHP. When you ran into use cases that demanded something the scripting language couldn't handle. Then you moved to compiled languages. These were more rigorous, serious languages, C, C++, Java. Compiling code was the first moment when we began to trade our innocence for power. If you didn't have a computer or a game console of your own, you just go over to your friend's house and play with theirs. They were the cool kids. Or if you had, say, an Atari 2600 and your friend had the Atari 5200, your friend was the cooler one and you'd spend the time at their house. Anybody remember the Atari 5200? The best joysticks. Then we hooked up our toys to networks, either with modems, LANs, DSL, or if your first computer was a smartphone, and I'm sure there's some of you for whom that counts, then you're young and beautiful and innocent. Enjoy your innocence. The network let you skip the magazine subscription, typing and compiling all together, and you could connect to other computers and then just copy the programs or files. Suddenly, the world seemed simultaneously vast and a lot smaller than it used to, thanks to the network. Now the cool kids were the ones who ran the computers on the network, the servers, and they'd run bulletin boards or forums or chat rooms. And when the internet happened, everything started to move to the network. We didn't even need to store things on our own computer if we knew that somebody else was storing it on their computer, and if we knew how to find it. Thus the advent of things like Yahoo. Programming changed too. Now you could write programs that depended on other programs that other people had written, and this made our programs more powerful. We could benefit from the good ideas of others and the hard work of others. But while these dependencies bring benefits, they signify another major step in the tragic death of our childhood innocence, managing dependencies. I got a glimpse of that the first time I ran Maven. I felt like I had just downloaded the whole internet. So many jars. It was fantastic. Who knows Maven? True or false? True. Yes. Dependencies are great, but they bring many dangers. They require strict version management. Dependencies that you blindly download might have security problems, and you might not be in a position to fix those upstream or deal with them. Dependencies can become abandoned. And dependencies have APIs that may or may not change, depending on how good the developers are. Dependencies have their own dependencies, and those might have further dependencies. And amazingly, in some cases, if you're not careful, they might have circular dependencies with version mismatches like that on the screen, so you might end up with multiple versions of the same package. Fortunately for us in the room, honestly, Composer does a very good job of avoiding that. But NPM, not so. That was our goal, though. Or what was our goal as a programmer? Originally, I just wanted to be Sid Meier. I just wanted to write games. At one point, I wanted to build all sorts of websites. I wanted to build a news aggregator. I could use the search company out there for that these days. I wanted to build a CMS for musicians. I wanted to build a learning management system to compete with Blackboard. I wanted to build a video rating site before YouTube. I wanted to build an app that recognized stolen violins. I wanted to build a specialized dating app. Those were my goals. And in all of the cases, the goal was an app or a website that did a specific thing. My interest as a developer was in solving real-world problems and creating specific digital experiences. Those goals would be the center red dot in my diagram. In my innocence, I thought that building those apps would involve lots of thinking about the actual functionality, user experience, and business models around those ideas. In reality, it was more like, I need a rating widget. NPM needs to be updated. The resulting new version of my XML parser dies on the manifest in a library I didn't know I had. My two-factor authentication on GitHub is expired. Pringles! Because at that point, it had exceeded the danger zone. And I just couldn't take it anymore, and I went and downloaded PHP Storm. So in each case, the innocent idea got worn down more and more by the need to maintain the tooling required to do development. Innocence didn't die there, but it was weakened, a little bit like Gandalf in Moria. Okay, Part 2, sysadmins. Remember the cool kids who could run their own servers. Let's call them sysadmins. They've also been tempted by the siren song of unlimited power, whereas they had innocently started their journey with the goal of running bulletin boards, forums, or sites that allowed them to communicate with other humans and have social contact without ever having to leave their bedroom, let alone turn on the lights or put on clothing. They too have lost their innocence. Linux captured their geek heart and soul. They initially loved Gentoo, Debian, and SUSE, but then along came slicker and more ambitious distributions like Red Hat and Ubuntu, and it was all in the promise of more power. It was no longer about customizing one distribution to be exactly the way a dream computer should be. Now it was about launching more and more and more servers to keep up with the demand of applications and sites that needed to be put onto the network, made internet capable. Then came virtualization, and everything could be done exactly the same way as before, but faster and with an extra layer of complexity, gracefully abstracted conveniently away by services such as AWS. The server admin clamored for tools like VirtualBox, VMware, Vagrant, chroot, cPanel, Capistrano, Puppet, Chef, Ansible, all great stuff. By the way, do you know how you turn on the fan in your laptop from the command line? Vagrant up. Not my joke, but thank you. Fast forward to modern times, and we've moved past virtual machines to containers. More buzzwords, more power, more complexity. The server admin is thinking about things like kubelets, pods, replication config maps, persistent volume claims, swarms, and trust. Meanwhile, to keep up and to be able to work together, the developer is thinking about things like Docker Compose, build scripts, deployment pipelines, local environments, QA environments. And the core problem here is that the sysadmins have gotten really, really good with all those powerful tools they have at creating big, arbitrarily complex infrastructures, which actually meet the demands of modern computing workloads. At the same time, developers have gotten really, really good with all their powerful tools they have at creating huge, arbitrarily complex application architectures, which, by the way, meet the demands of modern applications. And so eventually, these two breeds of power-hungry children, the developers and the sysadmins, slowly parting with their innocence and becoming drunk with new power, were shoved into the same room together and told to work together, to deploy together. Because the programmers couldn't do their work without all of that server stuff, and the server admins didn't have any reason to deploy servers without the programmers. So the result is that it's very hard for them to work together properly and account for all of the complexity at every stage of the development, testing, and deployment workflow. So now we have DevOps. It's the crossbreed between developer and sysadmin. And it's all with the goal of making developing, testing, and deploying these complicated applications onto complicated infrastructures possible. DevOps people are very lucky because they live in an age of amazing tools like Docker and Kubernetes. So now you come to a Laravel conference, or I heard him say Laravel. Laravel? What do people say? Laravel? Okay, I'll go with it. Which is presumably about the Laravel framework and the applications you build with it. It's like Linux, right? And you have a whole track here on DevOps, which is great and necessary. For example, you now attend sessions here at this conference about Docker. Docker has changed the paradigm of packaging, distributing, and running applications regardless of operating system, programming language, or architecture. We will cover all the essentials of building and running and sharing container images, image layering, and networking. You also have sessions at this conference about 12-factor Laravel apps. You resent your code base because it's hard to track down bugs. Stuff works on your laptop, but not in production. Or deploying an update requires a full day's work, this conference. Or Jenkins. For one reason or another, there are times when if we don't set up our own deploy process, there simply isn't one. Ouch. Even the session just before me had a whole section on how to do CI/CD deployment of an app, which was awesome, and kudos to that company because it looked great. It's a big topic. When application developers have to spend that much effort on DevOps issues, it's time to admit there's a problem. Someone has to stage an intervention. Hello, my name is Robert. I'm a developer, and I do DevOps. Hello, Robert. It's been 31 days since I've logged in as root. While awesome, the new breed of DevOps tools are for you, the application developer, just a distraction on the logic path of problem solving that you should be doing for your application. And you know what happens when you get distracted from your goal. Pringles. It might be useful to review everything that a web application needs to run, just briefly, okay? You need to build workflow for Composer and NPM. Not so hard. You need to think about the context in which your code runs, whether it's workers, requests, crons, or on the CLI. You need to store files on mount points, and you need backend services like a data, like MySQL or Postgres. You need MongoDB maybe, an indexer, Elasticsearch Solr. You need a cache, Redis. You need messaging, RabbitMQ, or some web-based equivalent. Cloud-based equivalent. You need routing, entry points, AP endpoints, redirects, rewrites. You need HTTP caching, like Varnish or CDN, and you need front-end related technologies like Vue.js, CSS frameworks, which you might offload to your front-end team. You need to think about performance optimization, and as you'll see in the next part coming up of my presentation, you need to think about security. You also have to think about all of those things on all of the different environments where your code's going to run, meaning your laptop, your dev, your test, your stage, and eventually your production environment. That's enough complexity for you to think about without also having to do kubelets, replication controllers, config maps, persistent volume claims, swarms, and trust. Right? I think so. Part 3, the death of childhood innocence. Who here has heard of Equifax? Please raise your hand. Great. Almost nobody. Equifax is an 800 million individual consumer database, okay? 800 million people in the database. They do over $1 billion of revenue a year, and they look at your ability as a consumer to pay or your credit history, and they can influence decisions that are made about you, whether you can open a bank account, buy a house, buy a car, even whether or not you can start an internet connection with a DSL provider for your home. I've run into situations where family members were unable to get an internet connection because of the data stored in this database. So this brand right now is such a mess of epic proportions, it's not a really easy subject to talk about. This is what their brand looks like on the internet right now. When you type for Equifax and you get the Google autocomplete going and you see things like stock dispute and security breach 2017 and Canada, you know you're screwed. So why is their brand so bad? Aside from the fact that Equifax was the subject of more than 57,000 consumer financial complaints about the data they stored recently, in September 2017, they also had a security breach where 147 million consumer records were stolen from their servers due to a software problem that I'll tell you about, including 209,000 credit cards and people's driver's license and social security numbers and addresses and basically all of the information you'd need to either steal money or do identity theft. 147 million records. So we're going to look at two aspects of the Equifax saga. Okay, we're going to first look at the infamous CVE 2017-5638. You know the one. I know you know CVE 2017-5638, right? Okay. No, that was the one where Struts, you know Struts, where Struts, the Java framework, had a 0-day remote execution code bug in it that was discovered and exploited extensively across the internet. But despite the fact that it was a 0-day security hole, Equifax failed to deploy the new package on their server, hosting something that led to their network with all that data for a while, a year. So that's what happened. How did they handle it? Well, the former Equifax CEO blamed the security breach on a single person who failed to deploy a patch. That was big of him, wasn't it? He just looked out into the room and said, yeah, you did it, didn't you? And they estimated in the fallout of their obvious, problems that this caused for them with regulation and lawsuits and breach of trust, that their valuation tanked by $4 billion. There's an interesting fact about that. At $4 billion, this one person who screwed up has more worth than Steve Austin, who's currently worth $29,791,399 adjusted for inflation from 1974. Who knows the $6 million man? Oops, nobody knows. What was the salary of that person who had the single task, you had one job, deploy, update this package? How much were they paid? How many of them could you hire for $4 billion? So the nice detail about that is the CEO actually retired with his $90 million in stock options and left the mess that had happened on his watch without any prosecution or litigation against him whatsoever, and he's just like sipping pina coladas somewhere on the island he bought. So who done it? Was this the fault of Gary, the developer? Gary, you did it. Who didn't apply that patch, didn't update struts? Or was it the manager, Diane, didn't implement GDPR on time? Something like that? I think this is actually the fault of the way we think about software. In particular, there's one aspect about thinking about software that's really culpable here, and that is that software is a function of time. And over time, things happen to software. You create new stuff, and you repair broken stuff. Just those two things over time. Creating new stuff is voluntary. You do that to yourself. Now, if you've got automation and CI/CD and all of that, then you are better off. You can catch your problems and you can fix your bugs better than if you don't have them. But if you've got broken stuff and CVE 2017-5836 is definitely broken stuff, that's a 0-day remote code execution flaw, then you have to deploy that an hour after it was released, or you get Equifaxed. So that was one topic. Now let's look at another topic. This is almost pure entertainment, okay? The brilliant, flawless response on the part of Equifax, aside from the CEO pointing the blame at one developer, included the logical thing to do when you've got 147 million people wondering if their data's been stolen. You erect a site on, of course, security.equifax.com on your own domain, which it conveys a certain level of trust and has validation possibilities with TLS certificates, et cetera, et cetera, et cetera. No, that would have been competent. You don't do that. If you're Equifax, you do something like equifaxsecurity2017.com, which instantly gets tagged as a spam site by OpenDNS and blocked universally. But even better than that, you go ahead and tweet the white hat phishing site that was set up specifically to prove that you could phish that site. So a white hat hacker actually set up, pay attention, instead of Equifax Security 2017, it's Security Equifax 2017, which promptly gets tweeted by the marketing department. So not only did they set up a site that resembles a phishing site, they actually directed their population to an actual phishing site. That stuff makes me hot. Oh my God. So they, of course, get caught on that and called out on that. And again, was it Diane or Gary's fault? Who knows? It's not about whose fault it was. It's about the fact that that site, making it, was a snowflake in their process. They didn't have a process for dealing with 147 million security data breach. They didn't have a process like that, so they had to do something completely new. And anytime that you have to do something in a mature organization where you don't have a process and you need it done today because it's an emergency, then you're going to go around all of the procedures and everything, and you're going to have to fill out IT forms and wait for them, but no, that's going to take too long, so you do it on yourself. You go to Namecheap and register what sounds like a good domain, and then you get Equifaxed. When you get Equifaxed, you experience the absolute horrifying death of childhood innocence. No more play, no more discovery, no more lightness, only darkness. Every character that you code after that will feel like bitter hard work and suffering. Wow, you're quiet. On to the rebirth of childhood innocence. So now we've seen how the childhood innocence of a developer dies. But is that the end of the story? Are we destined to fight with overwhelming complexity, distracting us from focusing our passions and ideas? Will the bad guys always be able to break in and steal our data? Are we all destined to have to become DevOps engineers? You, the Laravel developer, should be able to simply describe what you need for your application to run. You should be able to say, for example, I need PHP 7.2, and I need 50 gigs of disk space, and I'm going to use PostgreSQL, Elasticsearch, and RabbitMQ. And, oh, make sure my PHP dependencies get resolved, Composer and NPM both run, and all my caches get cleared every time I merge code. Because saving childhood innocence then means removing the complexity and the distraction that stands between you and your programming goals. Saving childhood innocence means not going outside of your circle of concentration when following the idea threads and problem solving. This is the advertisement. At Platform SH, we have built, it is possible, a Git-driven infrastructure where with a single push or merge, you can deploy an arbitrarily complex cluster to run your Laravel or any other type of app that you can think of, with microservices, message queues, the whole lot. If you create a new branch, you get a byte-for-byte copy of the entire running infrastructure, brand new, with all of the data copied really fast in less than a minute. Every Git branch has got its URL. It eliminates QA bottlenecks. It replaces things like Circle CI. You can run all your tests right on that infrastructure. You can integrate it with Bitbucket, GitHub, GitLab. We've measured it makes people like 14 times faster in testing and validation. Predictable deployments, because if you develop something on your feature branch and you merge it into your sprint branch and then you merge it into your QA branch, it's like exactly the same deployment routine that you use in every case. So if you have a security issue like replacing a struts or something, then you quickly clone your production environment, replace struts, test it out, merge it back in, and you know that if it's worked on one branch, it's going to work on the other branch. Uses all your favorite back-end services, all the ones I mentioned. And when we scale, it's got a unique triple redundant architecture where you can do zero downtime, scalability to literally hundreds and hundreds of CPUs and terabytes of RAM just for a single service like the database. You can scale anything as big as you want to go. It's multi-cloud, GDRP compliant, the works. And best of all, here at this conference, depending on your paper airplane foo, you can win this here rocket made out of Legos from this here innocent child. Sorry, Alphonse. Yeah, he's a nice guy. So that's just right out there. You see us there. Now, they told me that there were no questions, but they only told me after I'd made my slides. So I have to pretend that the slide up there right now doesn't say any questions. And instead, I'm going to tell you the story about Rasmus Lerdorf from the beginning, because that's a good way to use the last couple of minutes. So I came from the Drupal world. I was involved with Drupal from 2004, and in about 2007 or so, Drupal hadn't become a really big CMS, hadn't become one of the dominant players in the CMS space. That was yet to come, and we were looking for all our case studies that were going to help make that happen. And I would wake up in the morning in Europe, in Germany where I lived, and I'd open up my Skype and I'd talk to Dries Boitert, who was the creator of Drupal, and he lived in Antwerp at the time, so we'd have a nice Skype chat. And one morning I woke up and Dries said, "Hey, Robert, check this out. Yahoo launched a Drupal site, a real Drupal site. Look, it's labs.yahoo.com. And he sent me the URL, and I was like, oh, this is our breakthrough. This is going to put us above everybody else. Yahoo's the most famous end user of the Drupal framework at this point. This is going to be great. So I started clicking around. I was going to write a blog post, and I was going to, don't remember if Twitter even existed back then, going to do something with it, put it on Dig, I guess. And in my testing, I went to /user and discovered that, hold on, that's kind of odd. All of a sudden, I'm the super user. Yes, indeed, I was the super user with all the superpowers, the ability to completely configure or change the site, look at all the user records. All the data was mine. And I was like, ooh, I'm not going to publish this quite yet. We've got to tell Yahoo that they've screwed something up. So, have you ever tried to call Yahoo on the phone at 3 in the morning California time? Doesn't work. I tried calling the London office. They actually had an office. They were awake. But they didn't really get the urgency of the situation. And by the point I had called back and started working through all the people in their phone tree, and I was screaming into the phone, "What part of the Russians are going to hack you and you're going to lose your job? Don't you understand?" I realized they were all sitting in some cubicle and they knew I was coming, they just hung up on me. So I did the only rational thing that a guy's to do in a situation like that. I called the police. The Sunnyvale police from Germany in California and said, "You've got to go over to the Yahoo campuses, man. There's a security breach happening right now." I'm like, oh my God, is somebody crawling over the fence? No, not a physical security breach, network security breach, but praise the Sunnyvale police. They still went over. They contacted the night guard, who took the instruction, look up Rasmus Lerdorf in your phone book and call him. They did that. They gave him my number. He passed it on to his sysadmin. Sysadmins, they've got a great job, don't they? And they got in contact with me, identified the problem, promised to send a t-shirt, and never did. So thank you very much, everybody. My name's Robert Douglas. Thank you.